Now we're going to take a look at some other vertical shifts. Now first of all, we're going to look at f of x equals x squared minus 2, not plus 2. I think by now you can probably infer what's going to happen. So if we take x squared minus 2, so make d equal to negative 2, notice what happens to our parent graph here. It shifts down 2 units. So whenever d is negative, the transform graph will shift 2 units negative 2, it'll shift 2 units down from the parent graph. If we make d equal to negative 3, it'll shift 3 units down. As long as d is negative, the function, the transform function will shift down from the parent. Let's do x cubed and absolute value of x. Why not? Okay, so let's look at x cubed. If we make d equal to negative 2, again we can see all the y values go down. Let's reset that. Absolute value of x, let's make d equal to negative 2. All the y values go down. Again, I love how the vertical shift is so easy to see. Why is this? Well, we can see that when d is negative 2, the parent graph shifts down vertically, but why? Well, you're just taking whatever that y value was, and you're subtracting 2 from it. So if p of 1 is 1, the new y value will be 2 less than that, negative 1, because it's the same p of x except you're subtracting 2. And again, to see that on the graph, let's go back to x squared. P of 1 is 1, f of 1 is negative 1, it's 2 down. P of 0 is 0, f of 2 is 2 down at negative 2. Same thing can go for p of 2. P of 2 is 4, f of 2, well, it's just 2 less than p of 2, so it's just 4 minus 2. Therefore, it's a vertical shift of down 2. In general, we can see that when d is negative 2, the parent graph shifts down vertically, but why? Because, in this case, x squared is p of x. So when we see the x squared here, we can just replace it with p of x. Use a little arrow right here. And then, therefore, f of x is just p of x minus 2. It's just the y value of p minus 2 gives you the y value of f of x. Here's our proof, very simple proof. Suppose p of x is the parent graph and f of x is the transformed graph. I like to do this. Alright, so it follows that p of x minus 2 gives you f of x. If f of x equals p of x minus 2, so in other words, square root of x minus 2, x squared minus 2, it follows that p of x minus 2 equals f of x, so therefore all you have to do is the y values of p of x are shifted down 2 units to reach the y values of f of x. Here's what the chart looks like for x squared. We've already looked at this many times before. As you can probably infer already, we're just going to take the y values of p and subtract 2 since it's x squared minus 2. And now we have our new y values, 2, negative 1, negative 2, negative 1, 2, while keeping the same x values. Therefore, our transform chart, f of x equals x squared minus 2, is going to look like this. Again, for vertical transformations, the x values stay the same. In this case, negative 1, negative 2, negative 1, 0, 1, 2. We have new y values now. Wow, a lot of these look very similar, don't they? Lots of 2s, 1s, and 0s. That's going to be what our final chart looks like, which confirms this graph. If you have any questions about this, let me know.